So in this problem, we need to find the integral of secant x times tangent x dx. So what we can do is use our trigonometric formulas to rewrite secant x and tangent x in terms of sine x and cosine x. So we know that secant x is equal to 1 over cosine x. That's just the definition of secant x. And we know that tangent x is equal to sine x over cosine x. That's just the definition of tangent. So now we can multiply these two fractions together. So we'll have the integral of 1 times sine x over cosine x times cosine x, which is cosine squared x dx. So now this problem we can solve by doing u substitution. And what we want to substitute in for u is cosine x. Why? Because we see the sine x in the numerator, and that means that when we plug in u, we will take the derivative of cosine x, which is sine x, and that way the sine x will cancel out with the negative sine x, that is the derivative of u, which will just leave us the integrand in terms of u. So then we'll be allowed to integrate. So du, we're going to find the derivative of u with respect to x, so du dx. The derivative of cosine x is negative sine x. And then we're going to rearrange to solve for du. So du equals negative sine x dx. And then if we divide both sides by negative sine x, we'll have du over negative sine x equals dx. So when u equals cosine x, dx equals du over negative sine x. So we'll plug both of these into our integral. So we'll have sine x on top. And then we know that u is cosine x. So cosine squared x is just u squared. U is cosine x, so squaring that is just equivalent to cosine squared x. And from over here, we found that dx is equal to du over negative sine x. So we'll have du over negative sine x. Now we see why we took u to be cosine x, because now the sine x and the sine x here, we can just cancel them out. So what we're going to be left with is 1 over u squared. And this negative, we can just move that outside, since it's just a negative 1 that's being multiplied, and we can take constants out like that. And we're left with the du. So now we went from an integral in terms of x being integrated in terms of x to an integral with u being integrated in terms of u. So now we can just go ahead and integrate this. And the way I integrate this is just 1 over u squared. I just think of as negative u to the negative 2 power, and just do the reverse of power rule from there. So instead of subtracting 1 from the exponent, we're going to add 1 to the exponent. So we're going to have u to the negative first. And instead of multiplying by negative 2, we're going to divide by negative 1. So in power rule, you first multiplied by the exponent, and in the reverse of power rule, we're going to divide by the exponent after we've added 1 to the exponent. So this is the derivative, the integral of 1 over u squared, and we can't forget the negative out here. So now we have the negative there. Now let's move this u to the denominator, and we'll cancel out these two negative signs. So we'll just be left with positive 1 over u, because u to the first power is just, to the power negative 1 is just 1 over u. And then we're going to plug in our substitution for u back in. So we substituted u as cosine x. So that means we just replace it with cosine x. Oh, and we can't forget our plus c. So there should be a plus c after we integrate. But now we see that none of our answer choices look like 1 over cosine x, and that's because they converted 1 over cosine x to secant x. And we still have the plus c, the constant of integration. So 1 over cosine x is just secant x. And then we have our plus c. So this is the integral of secant x tangent x, and it's equal to answer choice A.